This unit introduces you to dyes and dyeing process. This unit comprises of 5 modules and a final review section that invites you to reflect on what you have learned. By end of this unit, students will be able to explain the importance and objectives of dyeing, identify the differences between dyes and pigments, define various terms used in dyeing process, describe how dyes are classified, describe the important features of various classes of dyes. Objectives of textile dyeing process. First, color the textile substrates like fibers, yarns, fabrics and garments uniformly and to produce the required depth of shade. Second, achieve acceptable durability of color to further treatments in production and normal end use. Third, reproducing the required shade from batch to batch. Fourth, using reasonably priced dyes and dyeing procedures. Fifth, operating according to ecological requirements and carrying out in the shortest possible time. Dyes used in coloring textile fiber or synthetic compounds. It serves as a useful dye. It should have the following features. First, intense color. It means how the dye impart color to textile materials. Second, solubility in water. During the process of dyeing, the dye particles, it should be soluble in water so that water can carry the dye particles towards inner molecular structure of the fiber. Third, substantivity to the fiber. It means how the dye molecule will penetrate inner molecular structure of the fiber. Fourth, durability to wet treatments. It means once the dye is penetrated inside that fiber molecular structure, what kind of chemical bond takes place in between fiber and dye molecules. That means that fastness, the color fastness property of the dye. If that color fastness property of the dye is strong, that produces required durability in various wet treatment process like washing, which is a regular process during the usage of textile products. Fifth, the dye should be safe, easy to handle and reasonably priced. There are 3 distinctive ways of imparting color to textiles. Method 1, aqueous or conventional dyeing. Method 2, pigments. Method 3, solution dyeing. Method 1, aqueous or conventional dyeing. This is the most important and most widely used method. The process involves the use of dye stuffs. It involves the treatment of the textile material in aqueous water solution. Method 2, pigments. Pigments are microscopic sized insoluble colored particles applied on textiles using special treatments. Method 3, solution dyeing. It is part of manufactured fiber production, involves adding micro-sized colored pigment to man-made fiber during manufacture. the pigment is added while the fiber is in liquid or solution form and before extrusion from a spinneret. This table displays the differences between dyes and pigments. Pigments have intense color. They are insoluble in water and common solvents. They are not made to have substantivity to fibers. The molecular size varies from small to large. They are stable to further treatments in production and normal use. The durability depends upon the binders that are used. Let me explain the pigment dyeing process. Here what happens? As you know that pigment, they will not penetrate towards fiber molecular structure. Then how the pigment can be applied? In this case, the pigments, they all mixed with binders, adhesives, that will stick on the surface of the fabric, so that the durability of pigment dyed fabric is mainly depends upon what quality of binders that are used. Let me explain the properties of dyes. Dyes have intense color. They must have solubility in water during the dyeing stage. Dyes must have substantivity to the fiber during the dyeing stage. The molecular size of the dye must be small enough to allow the dye molecule to penetrate the molecular structure of the fiber. They are stable to further treatment in production and normal use. The durability of dye depends on what kind of chemical bond between dye molecule and fiber molecular structure. Let us review some terms commonly used in dyeing process. Affinity. It is the term used to define the attraction between the dye and the fiber. For example, direct dyes have strong affinity towards cotton, means the direct dye have very high attraction for cotton. Substantivity. Technically, affinity and substantivity means the same. The dye which have a high attraction and which produces dark shade is said to be highly substantive on the fiber. Dye bath. For the reproducibility, all the amount of dyes and dyeing assistants and the liquor ratio used should be measured and recorded accurately in order to be followed precisely in future runs. All dyeing assistants in any dye bath should be used only if necessary. Using excessive amounts larger than recommended of any additive should be avoided. The concentrated dye solution. To ensure uniformity throughout the dyeing bath, a small solution or dispersion of the dye is made first. Extreme care must be practiced in the preparation of these concentrated solutions or dispersion. Undissolved or undispersed dye particles may cause unlevel dyeing or form specks on the goods. The dye solution is filtered through a coarse filter before entering the system. Also, when preparing concentrated solutions, dyes and dyeing assistants should not be mixed together in their concentrated form unless specifically required. Material to liquor ratio. This ratio indicates how much liquor, that is water, is to be taken for dyeing a given weight of the material. The total quantity of water to be taken for dyeing depends upon the weight of the material to be dyed and expressed in terms of ml ratio. Thus, A material is to liquor ratio of 1:20 means that the weight of the liquor to be taken should be 20 times the weight of the material to be dyed. Percentage of shade. It is based on the weight of the material taken for dyeing. Thus, when a 2% shade is to be produced on the cloth, then 2 grams of dye is taken for every 100 grams of cloth for dyeing. The dyeing so produced gives a 2% shade. It does not mean that the cloth contains 2 grams of dye per 100 grams of cloth after dyeing. Wash cycles. This treatment removes unbonded dyes and dyeing assistants from the fibers. The procedure varies from a mild rinse with warm water to the use of a detergent solution at or near the boil. With certain group of dyes, a slight change of shade occurs at this stage for yielding the original color. Bleeding of dye from a new cloth in the first laundering could be the result of poor rinsing in this final stage of dyeing process. Color fastness. Durability of color against various fading force like washing, rubbing, sunlight, etc. They are termed as color fastness to washing, color fastness to dry cleaning, color fastness to cracking, color fastness to sunlight, color fastness to perspiration, color fastness to saliva. The displayed diagram details the exhaust dyeing process. Classification of dyes. Dyes are organic chemicals capable of partially absorbing and reflecting visible lights. A dye should have two types of functional groups in their structure. Chromophores are responsible for providing color. Oxochromes are responsible for forming chemical bonds with the textile substrates. There are several different ways by which coloring materials are classified. The following are the most useful ones for the dyer. Dyes can be classified according to its solubility. 1. Soluble dyes, anionic or cationic. Disperse dyes, non-ionic, very slightly water soluble. Pigments, insoluble. Dyes can be classified according to the method of applications. In this case, the method of application, we are primarily focusing on various types of fibers. Acid dyes. Acid dyes are primarily used for protein fibers like wool, silk and polyamide fibers like nylon. Basic dyes. Basic dyes are primarily used for acrylics and basic dyeable polyester fibers. Pre-metallized acid dyes. These dyes are primarily used for protein fibers like wool and silk. Chrome or Mordant dyes. These dyes are used for protein fibers like wool and silk. Direct dyes. These dyes can be used for cellulosic materials like cotton, linen, flax, hemp and jute fibers. Azoic dyes. This also can be used for cellulosic fibers like cotton, linen, jute, etc. Vat dyes. It is primarily used for cellulosic fibers. Reactive dyes. This also mainly used for cellulosics and some other fibers. Sulfur dyes, mainly used for cellulosic fibers like cotton, linen and rayons. Disperse dyes, primarily used for polyesters, acetates, polyamides, acrylic and other hydrophobic fibers. Let us now look at some of the important features of various classes of dyes. Direct dyes. Direct dyes are derived from formulation of benzidine salts. They are water soluble and least expensive dyes. They are easily to apply and can be applied directly without pre-treatment, and fixing agents are not required. Direct dyes can be used only for cellulosic fibers like cotton, linen, jute, hemp and viscose fibers. Direct dyes are available in a wide ranges of colors and shades, not bright colors. Among bright colors, only bright greens, but it is more expensive than other color. Direct dyes have good color fastness to perspiration and dry cleaning. Light fastness varies widely from poor to very good. Some direct dyes are metallized with copper to increase their light fastness properties. In this case, copper salts are applied as an after treatment for improving light and wash fastness. Direct dye has poor fastness to washing and cracking. Direct dyes are used as background color for discharge printing. Reactive dyes. Reactive dyes are water soluble anionic dyes. Cold brand or Procyon type react at room temperature in presence of sodium carbonate. Hot brand or Procyon H type will react with cellulose in presence of sodium carbonate at the temperature range of 75 to 90 degrees centigrade. Remazole, vinyl sulfone reactive dye, will react in presence of base, undergoes an elimination reaction to form vinyl sulfone group, which then combines with cellulose. Reactive dyeing process is time consuming. Reactive dyes are primarily used for cotton and other cellulosic fibers at an alkaline pH of 9 to 12. Wool and silk as well as polyamide fibers in weak acetic dye baths. Reactive dyes are available in complete range of colors including bright colors. Reactive dyes have very good fastness to washing, good to very good fastness to light, good fastness to dry cleaning, perspiration and cracking. Reactive dye has poor fastness to chlorine bleaching. When we use reactive dyes during dyeing process, we can achieve uniform level dyeing. When we use reactive dyes in dyeing process, it has a high flexibility in the choice of method of application. The cost of using reactive dyeing is high because of cost of dye, loss of dyes during application and extensive washing. Reactive dye needs excessive time. Vat dyes are insoluble organic compounds. They are widely used for cellulosic fibers, produces good color range but limited selection of orange, blue and light bright green. Large amount of dyes are required for deep shade. They have excellent fastness to washing and very good fastness to cracking, perspiration, chlorine bleaching, oxidizing and high temperature treatments. Vat dyeing is expensive process because high initial cost of dye and method of application. Azoic or naphthol dyes. Azoic or naphthol dyes are ingrained dyes not readily available for instant application. Dyes are derived from arylamides organic compounds. They are insoluble in water and primarily used for cellulosic fibers. They produce full range of red colors and orange, brilliant yellow along with maroons, scarlet, deep black and burgundies. Azoic dyes lack green and bright blue colors. They have good color fastness to washing and dry cleaning. Poor to good fastness to light. Dark colors have poor fastness to cracking. The dyeing process is complex and it is time consuming. Sulfur dyes. Sulfur dye produces a complete range of colors in dull shade. They have poor light fastness in pastel shades. Sulfur dyes are mainly used for dyeing cellulosic fabrics in black, brown, navy blue or olive green in medium to dark shades. Some yellows and blues are available, but there is only one red and green type. Good fastness to light, washing, dry cleaning and perspiration. Sulfur dye has poor fastness to chlorine bleach. Sulfur dyed materials, when you keep it higher than normal room temperature, in presence of moisture tends to oxidize from sulfur acids, then cause tendering to cellulosic fabric. Basic dyes. Basic dyes are derived from salts of triphenyl methane derivatives. They are water soluble and contain cationic group. Basic dyes are mainly used for acrylic and modacrylic fibers. They can be effective for wool and silk but poor fastness properties. Also being used for nylon, polyester and cellulosic materials. Basic dyes produce a complete range of bright colors. Basic dyes, they have good color fastness to light, washing, perspiration and cracking for acrylic and modacrylic fibers. Very poor fastness to washing and light fastness on cotton, wool and silk materials. Acid dyes. Dyes of organic acids attract and attaches the color to fiber. They are available in the form of salts, water soluble and are applied in acid medium. They are mainly used for wool, silk, acrylic, nylon and spandex fibers. Acid dyes produces complete color range except bright red and greenish blue. Bright colors tend to bleed. Good color fastness to light, dry cleaning and cracking. Some colors have poor fastness to washing. Chrome or Mordant or metallic dyes. Metallic salts of cobalt, aluminum or copper are added to dye molecules for fixing dyes. They are water soluble and are applied with acid medium. Time consuming dyeing process. Dyes are applied in fiber, yarn or fabric form. Effective on wool and silk where maximum wet fastness is required. Acrylic, nylon, polyester and spandex are considered secondary importance. They have excellent fastness to perspiration and washing, good fastness to light and dry cleaning, very good fastness to cracking. Disperse dyes. These are non-ionic aromatic compounds with relatively low molecular weight and has an extremely low solubility in water. They are available in the form of powders, granular, liquid or paste. It has sublimation property at high temperature. Dyeing is carried out at high temperature and pressure. They can be used for heat transfer printing. Effective in polyester, acetate, triacetate. They can be used for nylon, acrylic and other synthetic fibers. They produce good color range except dark blue and black. Good to excellent fastness to perspiration, cracking and dry cleaning. Fair to good fastness to light and washing. When used on acetate fibers, poor fastness to light and subject to gas fading. You have come to the end of this unit. To summarize, in this unit, you have learnt about the objectives and importance of dyeing as well as the similarities and differences between dyes and pigments. You have also been familiarized with frequently used terms in the dyeing process, learned how dyes are classified and reviewed the various important features of various classes of dyes. Thank you.